Hey everyone, thank you so much for joining in and welcome to Edureka webinars. So folks, as we progress in today's session, we'll be learning one of the most important algorithm in machine learning, that is gradient descent algorithm. As we progress in today's session, we'll understand about the topics like what exactly is a cost function, and we will understand the overall meaning of this gradient descent, how it actually works, and then we'll look into the concept of learning rate, the mathematics behind this gradient descent algorithm. And then we'll also look into the topics like how to make sure that it works properly. And then the types of gradient descent. And at the end, we'll also look into it in a hands-on manner as how we can actually implement this gradient descent algorithm. So that's the agenda of today's session. As part of this curriculum, so this is how your overall learning journey would look like. You'll start by understanding what exactly is this deep learning, and then which is followed by how you can write the code in TensorFlow. This is followed by module 3, which is about the convolutional neural network. And module 4 is about the RCNN, that is regional CNN. And as you progress, the module 5 is about the Boltzmann machine and the autoencoders. And module 6 is GANs, that is generative adversarial network. And this is followed by module 7, which is about the emotion and gender detection. And module 8 is introduction to RNN and GRU, which is followed by the module 9 is about the LSTM. And module 10 is all about the hands-on implementation of LSTM and the CNN on one of the interesting application, that is auto image captioning, where you will upload a photograph and you will make the neural network to generate the text. So that's the application that you'll be building as part of this final module. As you can clearly see, you will progress in your learning journey from beginner to advanced, and by the end of this overall learning journey, you will be an industry-ready professional in the topic of deep learning. Okay, so coming back to our session's agenda. So let's understand what exactly is a cost function. Now, when we say that the cost function, okay, so a cost function is nothing but the loss function. Now, to give you an understanding as what exactly is this cost or what exactly is a loss, so let me give you an illustration of the same. So let's go to the TensorFlow playground. So I want you to observe the animation that we have got right here. So I'll keep it like this. I'll do some setting like this and I'll begin the training, and I want you to just observe it and then I'll explain what would happen. Okay, just observe. So if you have observed, so let me reset again. So this is how the distribution would look like. I have the orange data points, and inside the orange data points, I've got the set of blue data points. So this is how the given data would look like. Okay, so now what we are trying to do is we are trying to separate the blue data points with the orange data points. That is what we are trying to do. Now, on this data points to separate this orange and red, like orange and blue data points. So like when I say that I want to separate it in an effective manner. So this is a kind of pattern that I'll be looking at. See, if you look into this scenario, I've separated my orange data points with the blue data points. So this is the kind of pattern that I want to draw on this given data. so that my orange data points are separated from the blue data points. Now, how do we progress from this position? That is, assume this is my initial position. How do we proceed from this initial position to the final position that you see right here? So we need a way, right? We need a way to say that how exactly that I'm going about. Well, the way that we are going to take it as a reference in order to proceed towards the final position from the initial position is the value of loss. If you observe right now, once the pattern is found, the value of loss, the training loss that you see right here, it is 0.003. So that is the value of training loss that we observe on this given data after we find the pattern. Now, if I go ahead and restart it or hit the reset button, if you observe the training loss, 0.525. So when the data is randomly distributed, when I have not found the patterns in my data, then the value of training loss will be more. And as the model progresses, you can observe that the value of training loss is getting reduced. And at the end, it is going to reach a point when I have learned all the patterns in an efficient way. So this training loss or the overall loss value that we see, sometimes we also refer this as the cost function. We use this training loss or the cost function that you see right here as a reference value, which will tell us as how best our model has learned from the data. So that is the overall concept of this loss function. So a cost function or a loss function, it's a mathematical function. And here, this will help us to evaluate the performance of the machine learning algorithm. So what it does is it's going to compute the error for a single training example. Okay. It is going to find the error of the single training example. That's what the loss function is. Now, when we talk about the cost function, is the overall average of the loss function of all the training examples. Okay, so like when we talk about this loss, so it says that what is the difference between the expected value and the predicted value. Okay, that is going to give us the value of loss. Now, to help you understand this, okay, let's consider a scenario. Now, to help you get a clear picture, let's come back to the previous example that we have seen earlier. So this is a case where I have the value of loss like this. Now, in order to arrive at the value of loss, so I have various parameters. If I hover my mouse, see there is a weight of 0.19. And if I hover my mouse here, it says 0.40. So these are the initial values of loss. So if I hover my mouse, this is minus 0.24. So this loss is 0.36. So these are the various values of loss that we have got on this data. Now, as the training progresses, in order to reduce the values of loss, I'm going to update these parameters. See, or these are all parameters, which are nothing but the weights, as well as the bias term. If I hover my mouse, it says it's a bias, bias, bias. So I'm going to update the values of weights as well as the bias term such that the overall value of loss will be reduced. Now I'll begin the training again. Now, once the training is completed, I'll pause this. And if I hover my mouse, earlier it was 0.19. Now it has been changed to 0.17. Earlier it was 0.40. Now it has been changed to minus 0.84. Earlier, the loss was minus 0.24. Now it has been changed to 0.83. Earlier here it was 0.36. Now it is 0.31. That means it has updated the values of weights. And as a result of updation, the value of training loss has been reduced. Okay, so in this way, we can in this way, the value of loss will be reduced. Now the question is, how does this value of loss will be reduced, or how does this parameters get updated? Now, the way this parameter gets updated is with the reference to the value of loss function. So what we do is, in this scenario, for each and every parameters that we have, we will take up the derivatives. We'll take up the derivative of the loss function with reference to each of the parameter. So what is derivative? Derivative is nothing but if I change an parameter by a very small amount, what is the change that we get to see in the output? So the measurement of the changes by a very small amount is called as the derivative value. So in order to represent it mathematically, we will say something like this: del L by del W1, which is nothing but derivative of my loss function with reference to the parameter W1. And when I say del L by del W2, this is nothing but derivative of my loss function with reference to the parameter W2. So I'll take the derivative. Okay. Now, once I take the derivative, so the way that I'm going to update is, suppose if I'm updating the value of W1, I'll update as W1 is equal to W1 minus eta times del L by del W1. Okay, this del L by del W1 is called as a grad value or a gradient value. And this eta that you see right here, so this is actually a learning rate. Okay, now this W1 is my initial value or the previous value. So the way that I'll be updating as my new value W1, this will be a new value. To get the new value of the parameter, we'll consider its previous value and we'll perform the negative. That means we'll perform the subtraction of the derivative of this loss function with reference to the parameter, and we'll multiply it with the learning rate to ensure that we are moving in a slow manner. So just think about it. Okay, suppose you're standing on top of the hill. Okay, now you have a requirement to reach this position and you want to go up. Let's say this is a requirement that you have got as of now. So here, what you have to do is, this is your initial position and you want to reach this final position. Now, this eta is called as a learning rate. So you can think of this as a step size. Now, if your step size is very small, okay, so think about it, you're on top of the hill, and if your step size is very small, you're moving 1 foot at a time. So then you will take like large time, like more amount of time in order to reach your destination. Now, if your step size is very large, then that means like if you are, let's say you are a long jumper and you can jump a very long distance. So for each jump, you will cover, let's say 10 feet. I'm just giving you a very hypothetical example. Then this will be your first jump. And when you do a second jump, maybe you will jump right here. And when you do the next jump, maybe you'll jump back over here because you will jump only 10 feet at a time, because that's the distance that you are taking right now. So what you can clearly see is in this scenario, if your step size or your speed or the way that you were taking your steps from your initial point to the final point, if it is low, then you will take more time to reach the destination. If your step size is large, then you will miss it. You might miss the destination. So this is what happens when we are performing the update of the parameters and using the high learning rate and very low learning rate. Now, to illustrate the same, let's come back to our previous animation. So this time I'm going to reset everything and I'm going to increase the learning rate by 10. Now with my learning rate as 10, if I simply perform the updation, see, so I'm unable, this is where it stops. It is unable to reach the point which is best suitable for me. That means I'm unable to find the patterns between blue data points and the orange data points. So let me change it to 3 and let's see if it works. If I change it to 3, see how the system got changed right here. It is still unable to find the pattern. Now I'll give you another extreme scenario where I'll keep the learning rate as very small, let's say 0.0001. Okay. And if I execute the training, so now observe the update, how slow it is moving. See how, like, even with 500 epochs now, so it has still not found the best way. Like it still has not separated my data points in an efficient way. So if I update it, let's say this time to 0.01, and if I execute it, now it is much faster. And if I this time change it to 0.1, it is even better now. So this step size, what we call it in our deep learning, is actually a hyperparameter. If this value of hyperparameter is very large, we might miss the correct values. And if it is very low, then at that time, so it will take a lot of time to converge. So this is the role of the learning rate. So we have seen the overall idea right now. Whenever we are working, okay, so we want to update such a way that the parameters will be updated such that the value of loss will get reduced. Now, in order to reduce those value, we will take the derivative of my loss function with reference to my parameter that I have. So this is the overall concept of this gradient descent algorithm. Now, since the reason that we call it as gradient descent, because we are using the gradients, okay? We are using the value of gradients. Now, since we use this value of gradients and we are moving towards reducing the value of loss, that means if my loss value is over here, let's say my loss value is 100, I want to move towards the minimum value of loss. Let's say loss value is 0. So since I'm looking at the reduction of the value of loss, and I'm using the value of gradients to do that. Hence, we call it as gradient descent, because I'm descending from high value loss to the low value loss. That's the idea of this gradient descent algorithm. Okay, so what we will do is, so X1 represents the high value of loss, and I want to move towards the X5 where we have the value of loss which is minimal. Okay, I want to move from high cost region to the low cost region. That's the overall idea about this gradient descent algorithm. Now, if you try to visualize this in a 3D plane, this is how the 3D plane would look like. So you can clearly observe that this gradient descent is an optimization algorithm. So it's one of the common way to optimize the neural network. So what happens is, in this scenario, we are going to update the values of parameters such that the value of loss will be reduced. Now, this gradient descent is used in each and every kind of neural network. During the training, obviously, they have made use of transformer-based architecture of GPT. So for training that GPT model, they have obviously made use of this gradient descent algorithm. It's one of the core principles behind training of any neural network. Okay, so here, the key intuition is something like this. So let's say green is a data point and red is the data point that we want to reach. Okay, this is my initial point and this is my final point. So I want to move such a way that the value of loss will get reduced. Okay, that is the core idea of this gradient descent. So this is given by B is equal to A minus, like we are calling it as weighting factor, or which is also known as the learning rate. So learning rate multiplied with the gradient term. So that is how the gradient descent algorithm is going to work. Now, when the learning rate is very high, at that time, we might miss out, okay? We might miss out on reaching the final values. And when the learning rate is very small, it will take more number of epochs or more number of iteration to reach the best possible values of the parameter. So here, this slide talks about the number of epochs and how much it actually takes. And we have already seen this with an illustration. Okay, now when we talk about the mathematics of this gradient descent, so some of the key things that you need to remember to perform this gradient descent mathematically is, one is a power rule. So power rule is nothing but, suppose if we have a function which says as f of x is equal to x power n, then the derivative of my f of x is n into x power n minus 1. Okay, to give you an example, suppose if I have as 3 into x power 5, derivative of this 3 into x power 5 is given by 3 into 5 into x power 4, which is nothing but 3 5s are 15, x power 4. Okay, this is one of the main concept, that is my power rule. And the another concept that you need to remember is the chain rule. So chain rule is what we use it in calculus to find the derivative of the composite function. So as per the calculus, what it says is that if I want to if I have a derivative of, if I want to find the derivative of my z function with respect to x, where z is actually a function of x, and where sorry, z is actually like where, yeah, z is actually nothing but the f of y, and where y is given by something f of x, something like this. Now if I want to find the derivative of my derivative of z with reference to z, what they say is we can split this as del z by del y multiplied with del y by del x. So this is what we call it as a chain rule. Okay, now using this chain rule and the power rule, so we will generally make use of the cost function and find the derivative of that cost function. Okay, so to give you an example, suppose if I have a function as f of x comma y is equal to x power 4 plus y power 7. If I take the derivative of function with reference to each variable, so in this function, I have two variables, x and y. Okay, I have two variables, x and y. Now, when I have two variables, that is x and y, if I want to take a derivative of a function with reference to one of the variable, then from the calculus perspective, it is called as a partial derivative. So del f by del x is equal to, I'll take the derivative of the x, or like whatever the values of got x, and for the other variables, I'll treat it as constant. So del f by del x is given by 4 into x power 3, which is as per the power rule. In the same way, if I find the derivative of the cost function or the function with reference to y is given by 0 plus 7 into y power 6. Okay, so that is how we generally do that. Next, in this scenario, we are considering the equation of value of loss function. And once we find the value of loss function, then we will find the value of gradients. And while working on this loss function, depending on the situation, we might have, like, depending on the loss function, we might have multiple parameters. So since we'll have multiple parameters or multiple variables, we make use of the partial derivative. So in this scenario, we'll find the value of error, and for that value of error, we will find the gradients. Okay, we will find the gradients, and while finding the gradients, which we can apply the partial derivatives and treat one parameter as a variable and remaining as a constant, and we can apply the gradients and find the value of gradients. And after we find the value of gradients, so we will then update the parameters with this formula. So m is equal to m0 minus m1 is equal to m0 minus error into x into learning rate, sorry, error into learning rate. Okay, so error into learning rate into, I think there's also error. Okay, it's actually a derivative then. So error is nothing but the derivative into learning rate. So that is what we specify. Okay, so this is how we calculate the gradient descent algorithm. Now, in this scenario, okay, so just to ensure that there we have actually mentioned as how does the learning rate would look like, or which learning rate is actually suitable. So when it is very high, it will move in this way. Good learning rate is like a balance of low as well as the high learning rate. Okay. Now, when we talk about this gradient descent algorithm, so as you now have an idea that this is an algorithm that we use it to update the parameters of the machine learning or a deep learning algorithm. Now, while applying on the data set, so we generally make use of three different types of gradient descent algorithm. They are batch gradient descent, stochastic gradient descent, and mini batch gradient descent. So let's understand each of these methodology. Now, when we talk about this batch gradient descent, what we do is we will consider the entire data set. Okay, we'll consider the entire data set. For the entire data set, we will find the value of loss. And whatever the value of loss that we find on this value of loss function, I'll find the value of gradients. And then I will update the parameters. The key thing that you need to remember is we will find the value of loss by reference to my entire data set. In case of stochastic gradient descent, I will consider one row at a time. Okay, I will consider one row at a time. I'll take one row. Okay, then I'll find the value of loss. And from that value of loss, I'll find the derivative and then I'll update the parameter. Then I'll take the second row, I'll find the value of loss and I'll update the parameters. So I'll be doing one row at a time. That's the process of stochastic gradient descent. Now, in the scenario of this mini batch gradient descent, so we will make use of the batches. So when I say batches, maybe I'll consider few rows at a time. So an example is I'll consider 32 rows. And for those 32 rows, I'll find the value of loss and then I'll find the value of gradients. Now, once I find the value of gradients, I'll update the parameter. Okay, so in this way, we can implement any of these techniques. Depending on the use case, we can implement it on the data set. So is a batch gradient descent, stochastic gradient descent, and mini batch gradient descent. And we can control it by specifying the batch size. So this is the overall idea of this gradient descent algorithm. Now that you have the overall idea about this gradient descent algorithm, so let's implement this in an hands-on manner. So I'll take you through the notebook team. So this is the notebook which talks about the gradient descent implementation. So here I've started by importing the necessary libraries. So for demonstration purpose, I'm going to load the data set, which is make blobs data set, which is a demo data set given to us by the sklearn library. Okay, I'm going to load the necessary packages. And once I load the packages, I'll start by implementing the gradient descent with Python itself so that you can understand what is happening right here. So first thing that I've done is I have implemented the sigmoid activation, which is going to take the value and apply the function of 1 over 1 plus e power minus x. And the derivative of the sigmoid is given by x into 1 minus x. Okay. And in order to generate the prediction, so I'll take the dot product between x into w and I'll apply the sigmoid activation. If it is less than 0.5, I'll set it equal to 0. If it is greater than 0, if it is, yeah, so if it is greater than 0, I'll just set it as 1. So this is how I'm going to specify right here. Okay, so now what I'll do is I'll go ahead and I'll return the prediction. Okay, so next thing that I'm doing right now is, so this is the, yeah, this is going to return the value of prediction. and I'm just using the epochs as 100. Alpha is nothing but the learning rate. This is being used as 0.01. Next, we'll start by generating the data set. So this is going to generate a 2-class classification problems data set. And we'll generate X and you will generate Y. We'll reshape the Y to the required shape. Once that is done, we'll just prepare the data. And once we prepare the data, we are splitting the data set into 2 parts, training set and the test set. So here, once we split the data into 2 parts, we'll do one thing. So here we have created a loop. Okay. So in this loop, we are going through number of epochs that we have mentioned. So then we are generating the prediction. That is my forward pass. Then we are going to find the value of error, which is the value of loss value. Then we'll find the mean squared error. We'll find the derivative of the loss function. And once we find the derivative of the loss function, we'll update the values of the parameters. Okay, and then we'll just go ahead and apply the fit. Now, if you look into this scenario, my original value of loss was 284. And as the training proceeded by the end of 100 epoch, so my loss value is 0.3430. That means we were able to reduce the value of loss from the initial value of 284. So that's how the gradient descent algorithm helps us to reduce the value of loss. Now, here in this scenario, we're just trying to evaluate the model, and this will give us the overall evaluation of the model. So the overall pattern in which that we have observed on the training loss is this. Okay, so in this way, we can implement the gradient descent algorithm from scratch with the help of Python programming language. All right, team. So with this, we come to the end of today's session. Thanks a lot, everyone, for joining in here. And I really wish you all the very best in your upcoming learning journey. Take care, everyone.